Now I'm going to discuss with you the distance versus time graph and the speed versus time graph. So let us now have a look on these two cars. The first one has speed 5 meter per second and the second one has speed 10 meter per second. As you see here, the first one will move 5 meter every second and the second one will move 10 meters every second. Now we will see how the graph of this motion look like. The first graph that we will draw here is the speed versus time graph. As you saw before, for the first car, it moves with constant speed 5 meter per second, means that the value of the speed is always constant. So in 1 second it's 5 and then it's also 5. So if you connect these points, you will get a horizontal line like this. This is the speed versus graph for car A. And for car B, since the speed is 10, so the value will be here, and then the same, if you connect these points, you will get a horizontal line. So keep in mind that if you have a constant velocity motion, the speed versus time graph will be a horizontal line. But from here you can see that the value of the speed of B is larger than A, so we can say that car B is faster, but car A is slower. Now we would like to connect between the speed versus time graph and the distance versus time graph. We will use the car A as an example. So car A is moving with constant speed 5 meter per second, meaning that every second the value of the speed is constant. So if you connect again, we will get a horizontal line like this. And if you remember the distance traveled by car A, the distance traveled every second will be 5 meters. So in the first second here, the distance will be 5 meters, and then after 2 seconds, the distance will be 10, and then after 3 seconds, the distance will be 15, and so on. So if you connect these points, you will get a straight line like this, but this is not horizontal. And if you have a look here, you will see very interesting point that let's find the area under the speed versus time graph here. We have an area here that the value is 5 times 1. So you'll see that the area is 5. And this is actually the value of the distance until 1 second. If you find the area until 2 seconds here, you will get that the value of the area is 5 times 2, and it will be 10. And that's the value of the distance at 2 is equal to 2 seconds. And later, if you calculate the area until 3 seconds here, you will get 15. And that's the distance at t is equal to 3. So the first interesting point here, that if you have a speed versus time graph and you calculate the area under the graph, you will get the distance. Now let's draw the distance versus time graph for the both cars. So the first one has a speed 5 meters per second, and after 1 second it will move 5 meters, and then after 2 seconds it will move 10 meters, and after 3 seconds the distance will be 15, and after 4 seconds the distance travel will be 20, and so on. So this is the distance versus time graph for car A. And now let's draw also the distance versus time graph for car B. And as you saw before, the car B has a speed 10 meters per second, meaning that every second the distance travel will be 10 meters. So after 1 second the distance will be 10, and then after 2 seconds the distance will be 20, and then after 3 seconds the distance will be 30, and so on. So if you connect these points, you will get a straight line like this. And this is for car B. And you can see here the difference, that car B has the speed larger than car A. So we can say that car B is faster than car A, or car A is slower. And from the distance versus time graph, you can also see this magnitude. I mean, you can see from its slope. If the graph has a bigger slope, like car B here, that means the speed is faster than the one that has a smaller slope. So the bigger the slope is, you get the faster speed. Now the last thing here that I would like to discuss is the relation between distance versus time graph and speed versus time graph. So as you saw before, from speed versus time graph, you can get the distance traveled by the object by calculating the area under the speed graph. So now if we have distance versus time graph, we can also find the value of the speed. So let's say you have 2 points here. This is the first one, and then this is the second one. And from the difference at the vertical direction here, we can say this is the delta D. And also the difference from the horizontal here, let's say this is delta T. You can calculate the value of the speed. So for example, using these 2 points, we get that the delta D here is 20 minus 0. So you will get 20 meters. And the value of delta T here is 4 minus 0. So you will get 4 seconds. So if you divide delta D by delta T, here you will get 20 meters divided by 4 seconds, or 5 meters per second. And that's the speed of this object. So if you draw the speed versus time graph, you will get that the speed is 5 meters per second. Of course, this is the simple mathematic to obtain the speed, but that's the basic idea if you want to go further using what's called derivative or calculus. But don't worry about it, we will get into that later. Now let me summarize this way. If you have a speed versus time graph like this, and you want to get the distance, so from speed versus time to the distance, you can calculate the area. So the area here will be the distance traveled by the object. But if you have a distance versus time graph and you want to get the value of the speed, you can find the slope. So it's the delta d in the vertical here divided by delta t. So the speed will be delta d divided by delta t.